Hello, and welcome to the new section of my series on CSEC Mathematics. This section is called Measurements, and we will start by talking about units. By the end of this lesson, you should be able to identify and use the correct SI units for different types of measurements and perform conversions between units. We will start using what we learned in the first three sections of the series from now on. SI units are the foundation of measurement in science, technology, and everyday life. They ensure that everyone throughout the world is on the same page when it comes to quantifying and comparing data. These are the 7 base units from which all other units are derived. In this section, we will focus on length, mass, time, and temperature. The remaining units will come up in your science subjects. These 4 units will be enough to understand how to convert between units. Now I would like you to pay attention to the unit of mass here. Unlike the others, the base unit of mass is the kilogram, not the gram. Later, when we talk about prefixes, you will encounter the prefix kilo, which means 1000. But in the case of mass, the base unit itself is already 1000 grams. It is our starting point. So when you see kilo in other contexts, like with meters or with bytes, it means 1000 times the base unit. Derived units are created by combining base units through mathematical operations like multiplication or division. Even though this will be better understood in the algebra topic, let's still look at how units are derived. Area measures the size of a surface. When we calculate the area of something like a rectangle, we multiply its length by its width. Both are measured in meters. So when we multiply the length by the width, we will simply say we multiplied 2 meters to get meter squared. Now, similar to how we use a formula and algebra to manipulate the units of the quantities, to get the derived units, we can do the same with other quantities, such as volume, which is the product of 3 lengths, meter, 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 meter cubed. Or speed, which is the distance measured in meters divided by the time in seconds. And we'll get the unit meters per second. Now, sometimes while working with units, you are required to convert the units. One way is to be familiar with SI prefixes. They represent powers of 10 and help us express large or small quantities efficiently. For example, kilo, represented by the symbol K, has a factor 10 to the third power, which is 1000. Because the power is positive, we are supposed to multiply the base by 1000. Also, milli, represented by the symbol common M, means that we divide by 10 to the third power. We know it's divide because the power here is negative. Now, these are not all the prefixes. If you want a full list, you can let me know or research it yourself. These are sufficient, however, for whatever you may encounter in CSEC Mathematics. By using prefixes, we can easily convert and understand measurements across different scales. This is particularly useful in science when you remember the meaning of a prefix. For instance, remember that kilo is 10 to the power of 3. So anything kilo will be 1000 times the base unit. 1 kilogram is 1000 grams. 1 kilometer is 1000 meters. Also milli. It means divide by 10 to the power of 3. So anything milli will be 1/1000th of the base unit. In this case, it is 1/1000th of a gram or 1/1000th of a meter. Now, let us look at a few examples. We will use our method of convenient 1 to do all the conversions. The first question requires us to convert 3.5 kilometers to meters. First, we have to know the equivalence for the meter. We know that 1000 meters is equal to 1 kilometer. I am required to convert 3.5 kilometers. I need to put this in a ratio such that kilometers cancel out. So I will write 1000 meters over kilometer. This is in essence 1, since 1 kilometer is equivalent to 1000 meters. So I take my 3.5 kilometers and I multiply it by 1 in a convenient form. 3.5 kilometers times 1000 over 1 kilometer. Cancel, cancel. 3.5 by 1000, 3500 meters. Now, you may think to yourself, well, I know you can just simply multiply by 1000. The reason I'm showing you this is for when you have compound units. When you have multiple units It's easier to use this method because you can simply separate each of the units that you're required to convert. Let's look at the mass example. Convert 250 grams to kilograms. All right. Again, we first require an equivalence. We know that 1,000 grams is equal to 1 kilogram. We are required to convert 250 grams. We're going to do this by multiplying by a convenient number 1. So that means I need to write this in a ratio such that I will be able to cancel off the grams. That would be 1 kg over 1,000 grams. And I simply replace the 1 with this. So 250 grams multiplied by 1 kg over 1,000 grams. G's cancel. 0 cancels here. 25 into 25, 1. 25 into 100, 4. And we get 1/4 of a kilogram, or 0.25 kilograms. Next, we're required to convert 5,000 cm squared to meter squared. All right, we're required to convert this. I've never, however, seen cm squared given to me. How do I solve this? The first thing I know is I know 1 meter is equal to 100 centimeters. But I need centimeters squared. So if I square both sides, I would be able to get something with cm squared. This is the same as 1 squared, meter squared, equal to 100 squared, cm squared. That means 1 meter squared is equal to 10,000 cm squared. Okay, I need to write it in a form of 1 so that the cm squares can cancel. So I'll write 1 meter squared divided by 100,000 cm squared. And if I have to multiply this by a convenient form of 1, I will choose this so that I can get it in the units I desire. 5,000 cm squared times 1 meter squared over 10,000 cm squared. This will cancel with this. 1, 2, 3 zeros cancels with 1, 2, 3 zeros. 5 into 5, 1. 5 into 10, 2. And then I work that out. 1 m squared over 2, or a half meter squared, or 0.5 meter squared. Next, I'm required to do a volume example. Convert 2 cubic meters to cubic centimeters. Now we're required to convert to cubic meters. I don't know any conversion for cubic meters to cubic centimeters. I do, however, know that 1 meter is equal to 100 centimeters. Therefore, if I want something in cubic meters, I would need to have a m cubed. So I cube this side, and since it's equal, I have to cube this side as well. So, therefore, that means that 1 m, and I should just put the cubes here so you can see what's happening. And then we expand. All right, that's the answer for this one. Now, let's talk about something that you will encounter during this section as well, which is capacity. Capacity refers to the volume of liquid that a container can hold. It is usually measured in liters or milliliters. For conversions involving capacity, there are 2 things to note. One is that the base units of capacity is the liter and not the milliliter, similar to how the base unit of mass is the kilogram and not the gram. And number 2, 1 cubic centimeter is equivalent to 1 milliliter. Let's look at an example. Convert 3 liters to milliliters. So let's summarize what we did today. In this lesson, we began by introducing the base SI units, which are the building blocks for all measurements, and this allowed us to identify the appropriate units for mass, temperature, and time. We then explained how to obtain derived units by combining base units through multiplication or division, giving us the units for area, volume, and capacity. After establishing these units, we discussed SI prefixes, which enable us to perform unit conversions between various units of the same measure by using the method of choosing convenient ones. Thank you for joining me in this lesson on units. In the next lesson, we will learn how to calculate the perimeter for various plane shapes. Feel free to leave any questions or comments below. Don't forget, you can join the Google Classroom for the series resources. See you in the next lesson.